In Notes 5.3a, we are going to focus on writing formulas for ionic compounds. Recall, ionic compounds are those compounds that exist because of ionic bonds, and ionic bonding is the result of electrons being transferred from one atom to another. For this video, you are going to need a periodic table, so if you don't have one, please pause the video, grab a periodic table, and then get ready to start it again. So before we get into writing chemical formulas, we have to talk first about oxidation numbers. Oxidation numbers are numbers that indicate the charge on an ion. So for example, if I were looking at something like sodium, Na, I know that sodium is found in group 1, therefore it has one valence electron, and we know that sodium wants to lose one electron, and if it does, sodium gets a charge of +1. And so we would say that the oxidation number for sodium is +1. So oxidation numbers are going to tell us the charge of an ion when it either gains or loses electrons. The oxidation numbers can be found on the front side of our periodic table. And so if you flip to the front side of your periodic table and you locate the key in the lower left-hand corner, you will see that right here is what's known as the oxidation state. Okay, the oxidation state is going to tell us what the charge of that ion is. So in this key, we see an oxidation state of 2. So the charge of that ion becomes +2. Okay, you will notice that some of the atoms have multiple oxidation numbers, so they could have plus or minuses. And so we're not really going to use the front side of our periodic table to help us figure out the oxidation numbers. Rather, we're going to focus on the back side. So if we flip to the back side of our periodic table, we can see that common oxidation numbers are also given in an additional table. And so this additional table is what you see right here. This table is going to make writing chemical formulas and naming chemical compounds extremely easy. Nothing on this chart needs to be memorized. Remember, you will always have access to it when taking any type of test or quiz. It is really just a matter of knowing how to use the table. So the way that this table works is you will notice it's divided up into our positive ions on the left-hand side and the negative ions on the right-hand side. For each one of the elements listed, then, it's going to give you the element symbol and the charge. So if I look down below here, I see that zinc, Zn, +2. So the oxidation state for zinc is +2. Okay, if I were to look on the anion or the negative ion side, I see this bromide here is Br, and the oxidation state is -1. Okay, a couple of things we want to note about oxidation numbers. First of all, if we were to look at the front side of our periodic table, the group 8 elements, remember those are our noble gases, do not form ions. Therefore, they have no oxidation numbers. Okay, so we're not going to be making compounds with any of those noble gases. Second thing we should notice is that our transition metals, remember those metals found in that part B of our periodic table, can have multiple oxidation numbers. So if I look on this table, I can see iron here is listed with multiple oxidation numbers. We can have iron with a +2 charge, we can have iron with a +3 charge, and we'll talk about kind of how we address that or how we know which one to use a little later on. Okay, so this table, these oxidation numbers are what we are going to use when we determine the chemical formula for an ionic compound. Okay, the last thing we need to talk about is this idea of a polyatomic ion. Okay, in the term polyatomic, poly here means many, and so a polyatomic ion is defined as a tightly bound group of atoms that behave as a unit and carry a charge. Okay, if we break it down, poly meaning many, atomic meaning atoms, it's literally an ion composed of more than one atom. Okay, the common polyatomic ions are also found in that chart on the back of our periodic table. And again, there's absolutely no memorization involved with this. It is really just a matter of, can you find these ions? Can you locate the charges? So if I look, for example, let's say you were given the polyatomic ion SO4. Okay. If we look at SO4, we notice it is a combination of one sulfur ion and 4 oxygen ions. However, this entire thing behaves as 1, and the entire thing has a charge of -2. Okay, and so we are going to keep this as is. So if I look for SO4, it is negatively charged, so it's going to be here on the right-hand side of this chart. When I go to look for the SO4, I'm going to find it down here at the bottom. Okay, SO4 we will see has a charge of -2, and the name of that ion is sulfate. And so I would call this the sulfate ion. Okay, we want to be careful because directly below it is an SO3, which is -2, which is sulfite, but this in case we're looking at the SO4. Okay, I could find the NO3 on the video, or on this chart. NO3 here is called nitrate, so we'd call that the nitrate ion. If I look for CO3, CO3 here is carbonate, okay, etc., etc. If I look down below, these last two, C2H3O2, again, this is 3 different elements, but it behaves as 1 unit. That entire thing carries a charge of -1, and that is my acetate ion. NH4 is our only polyatomic ion that is positively charged, and I'm going to find that right up top here, okay, and I will see that that is called ammonium. Again, no need to memorize any of the polyatomic ions, the formulas or the charges, but just a matter of understanding where to find them and how they work. All right, so let's get into writing formulas for ionic compounds. Okay, the most important thing to understand about an ionic compound is ionic compounds are electrically neutral. Okay, electrically neutral meaning positive ion charge and the negative ion charge must balance out. So at the end of the day, the net charge of our compound needs to be 0. So if I have a compound made up of a +1 charge and a -1 charge, I can add the total charge together and end up with a net charge of 0. And so that's my goal when I'm writing ionic compounds. Okay, the easiest way to learn how to write ionic compounds is to just go ahead and do it. So we're going to try to write the formula for a compound made up of potassium and chloride. Okay, again, we want to use the chart on the back side of our periodic table to help us do this. And so the first thing I'm going to do is I'm going to locate both of these ions on the back of the table, along with the element symbol and the oxidation number, or the charge on that ion. Okay, we will see that the potassium is found on the left-hand side in the cation chart, and the symbol for potassium is K. The charge on that cation is +1. On the right-hand side, I locate chloride, and I see the formula for chloride is Cl, okay, capital C, lowercase l, that is the only acceptable way to write the formula, and the charge on the chloride ion is -1. So that's step 1, simply locating the ions with the symbol and the charge. Okay, the next thing we want to remember when we write a formula is that the positive ion always goes first. So when writing a chemical formula, the positive ion is going to be listed first. In this case, potassium is the positive ion. Okay, so we're going to start by just writing the element symbol for potassium, followed by the element symbol for chlorine, which is a capital C, lowercase l. Okay, we want to be careful with how we write these element symbols. Writing capital K, capital C, capital L is incorrect. Likewise, writing capital K, lowercase c, lowercase l is incorrect. The first letter of an element symbol should be capitalized, the second letter is not. Okay, now what we have to remember is that compounds are going to be neutral. So if potassium has a +1 charge and chlorine has a -1 charge, if I have one of each of those ions, the overall charge should be 0. And again, I can say +1 from the potassium plus -1 from the chlorine gives me an overall charge of 0. And so written as is, KCl is a neutral compound. And so the chemical formula for the combination of potassium and chloride is KCl. Okay, let's look at another example, calcium and bromine. So once again, I'm going to start on the back side of the periodic table. I'm going to find calcium. Calcium is Ca plus 2. I locate bromide on the anion side, and Br is minus 1. Ionic compounds are always going to contain one positive and one negative ion. Okay, so calcium is plus 2, bromine is minus 1. We want to remember that the calcium is the positive ion, so it gets written first. The bromine is the negative ion, so it gets written second. So I have CaBr2, or Br. Capital C, capital B, and the other letters are lowercase. Now, if I were to just keep this chemical formula as is, one calcium ion with a plus 2 charge added to one bromine with a negative 1 charge is going to give me an overall charge of plus 1. Okay, and we can't have that because we need our compound to be electrically neutral. So in this case, we can't just have. So the way that I'm going to combat this overall charge of plus 1 is adding another bromine. So by having 2 bromines, now the overall negative charge is negative 2, and so the overall net charge of my compound is 0. Now, to show the fact that I've added an additional bromine to my compound, I am going to use what is known as a subscript. Okay, I'm going to add a subscript of 2 next to the bromine. Okay, this subscript of 2 applies only to the bromide ion. Okay, and it's saying that I need 2 bromines. It does not tell me how many calciums they need, and it's a subscript, meaning it's written below the element symbol. So the final chemical formula for the combination of calcium and bromide is CaBr2. Okay, now a couple of other things to note about this. First of all, although it's not written, it is implied that there's a subscript of 1 here. Okay, when writing chemical formulas, we never write subscripts of 1. The other thing we want to know is that we use these charges and these oxidation numbers to help us determine the chemical formula. However, they do not actually show up in the chemical formula. So writing a chemical formula for the combination of calcium and bromide as Ca plus 2 Br minus 1 with a subscript of 2 would be incorrect. Okay, so let's look at a couple of more examples. Okay, let's say that we want to write the chemical formula for aluminum and oxide. Okay, this type of atom, we might want to use what is known as the crisscross method to come up with the formula. The crisscross method is useful when the ion charge crosses over to be used as the subscript of the opposite atom. And again, this is useful when the charges don't balance out easily. So if we were going to write the formula for the combination of aluminum and oxide, again, we're going to start the same way. If I look up aluminum, I see that aluminum has symbol of Al, the charge is plus 3. Oxide is O, minus 2. Okay, and when I go to try to figure out the formula for this, having a plus 3 charge and a minus 2 charge can be a little tricky. And so I can use the crisscross method. The crisscross method works like this. I'm going to start by writing the symbols for my ions. Again, the positive ion goes first, Al plus 3, O goes second because it's negative. Okay, the charge of this aluminum ion then is going to tell me how many oxygen atoms are in my compound, and the charge of the oxygen atom is going to tell me how many aluminums. So the final formula for this compound is Al2O3. Now, the actual plus and minus signs aren't carried through, but the numbers can be carried through to determine the subscripts. Once again, the positive ion is written first. I don't include any of the charges in my compound, and my subscripts apply only to that atom. Okay, so the crisscross method is something that you can use all of the time if you would like, or you can use it just for charges that don't necessarily balance out easily. Okay. All right, so let's look at some additional examples. Let's say I want to write the chemical formula for the combination of calcium and the nitrate ion. Nitrate is one of those polyatomic ions. So if I look up on the back of the periodic table, I say Ca is plus 2, nitrate is NO3 minus 1. Okay, NO3 is the formula for the nitrate ion. The charge then is -1. Okay, if we go to do the crisscross method for this, calcium is Ca plus 2, nitrate is NO3 minus 1. Okay, positive ion goes first, so I start with the calcium followed by the nitrate. This 2 here is going to tell me that I need 2 nitrates. The -1 here is going to tell me I only need 1 calcium. And so when we need multiple of the polyatomic ions, we're going to put them in parentheses. So I'm going to put the NO3 in parentheses, like you see here, followed by a subscript of 2. This 2 tells me that I have 2 of the nitrate ions. Okay, if I wanted to break it down, I could say that, well, there's 2 nitrogen ions, and there are 6 oxygen ions. But as a whole, there are 2 nitrate ions. Okay, so if you have more than one polyatomic ion, you don't change the subscript. Instead, you keep the formula or the subscript for the polyatomic ion intact and then put the entire thing in parentheses with the proper subscript on the outside. Okay, let's do another one of these. Let's say I want to do ammonium and phosphate. Ammonium is a polyatomic ion, and if I look it up, it's NH4. The entire charge of that ion is +1. Phosphate is PO4, and the entire charge of the ion is -3. Okay, so I'm going to start with my positive ion. Notice it's NH4, followed by my negative ion, PO4. Okay, they're polyatomic, so they're all capital. I don't change the subscripts for those polyatomic ions at all. And now 1 + 1 charge of the nitrate is going to tell, or of the ammonia, excuse me, is going to tell me how many phosphates I need. The 3 charge of the phosphates are going to tell me how many ammonias I need. And so in order to have a neutral compound here, I'm going to put the NH4 in parentheses, followed by a subscript of 3, and then the PO4. Now, since I only need 1 of the phosphate ions, I do not have to put that in parentheses. So my final formula ends up looking like NH4 in parentheses 3 PO4. Okay, so one more example. Magnesium and the acetate ion. So I look up magnesium. Magnesium is Mg plus 2. The acetate ion is a tricky one. It contains 3 elements, but we copy it exactly as we see it. C2H3O2. The charge of the acetate ion is -1. Okay? Copy it down. Mg, C2H3O2. The 1 here tells me how many magnesiums I need, so I'm good there. The 2 here tells me how many acetates. So I need 2 acetate ions to balance out the +2 charge of magnesium. So I'm going to put the acetate in parentheses, followed by a subscript of 2. So the final formula here is Mg parentheses C2H3O2 parentheses with a subscript of 2. So that is how we write the formulas for ionic compounds. The key thing to remember is ionic compounds are electrically neutral, so the overall charge of the compound should always be 0.